Hey guys, how's it going? More back on that bandsaw setup. I've done some more to it and educated myself some more, which probably should have done before I started digging into it. But again, sometimes it's fun just to go for it, and that's what I did. So, feet per minute versus RPM. You know, one correlates to the other one depending on what pulley you're running through that RPM. So that's not a one-to-one. And in my case, I was probably running about 700, about 1,000 feet per minute after I slowed it down, I think. And now I had to get it into the correct window, which should be for steel between 100 and say 300, probably closer 150, whatever. 150 is a good shooting point, and depending on the material, whether it's thicker, thinner, thinner the material, the faster you can run it. The thicker material, the slower you got to run it. The idea is you're trying not to overheat the blade and shear the teeth off. Once the teeth start getting hot, they will give up the ghost and lose their edge. So that's what you're trying to avoid. And that's what I'm doing with this. I did some more modifications to it, kind of like I think what I talked about in the last video. And that's what I ended up doing, was taking it and adding a making a jack shaft out of where the motor was. The motor before was sitting up here and was a direct drive to drive this axle. I made up a new axle with pillar blocks to support it, and I got a 7-inch pulley on the back, and this is a variable speed pulley. It goes from, I'm gonna call that a 5-inch pulley, 4.5-inch pulley, down to about a 1.5-inch pulley, and with that gives you a ratio of your speed. And what I made here also is the motor is mounted on hinges and it's adjustable. There's hinges welded under there. That was from that free pile from that house. Took 2 of those hinges and put it on the bottom so that the motor can rock. And basically what you do is you loosen this guy up, and it'll allow you to slide on this piece of metal and pitch the motor, and by pitching the motor it will change the speed of that. I'll show you that in a little bit later. Just want to show you what was put together, So it's pretty stout. I'll go and pop that cover off of there, and I'll show you the insides, the innards. And I took the switch. The switch was mounted the other direction through the box, inside the box, and then the switch itself would stick out of the hole. Actually, didn't like that much. Wanted to run the wire externally. I didn't want to try snaking it through the stuff inside, so just popped it on the other side and ran it right to the motor. I'll tie it up with something, probably right up here. Steer it in some kind of direction like that, So that'll be that, and the regular cord's just plugged in. I'll turn it on. Turn it on. Well, I had to cut a hole for this shaft to stick out of, because I used that as the drive. But it's on high speed now. And it still cuts wood nicely. One side of this thing has staples in it, which is that side. So we want this side. Do some carving. So you got the idea. I mean, it still works very well, even for cutting wood. Now there's going to be a metal blade that's on there, so it should still cut wood, but it's not going to be as efficient. It's not meant to dig out as many chips as wood is, so that's what's on there. So I'll go plop you down over here and I'll show you the inside. Again, you think I would have had this set up, right? I made some neat wood chips. I'll set you on some wood chips. There you go, nice little arc. Alright. So it's basically, it's the whole structure just put back together again. Now you can see its innards. And what I ended up doing, first there's the pillar block. It's actually 2 pillar blocks bolted together, and I just drilled a hole through the frame. And the frame's fairly thick. It's probably about 3/8. And so that holds the 2 pillar blocks straight. And then I just took a bolt and stuck it in the top. And the bolt, I actually cut a little bit of the bolt out of it, so that if I wanted to, it'll swing pretty far on tensioning it. And I went with a different drive belt. I had to. The other belt that was on there, basically was like a rubber band. You could just keep pulling it and pulling it and pulling it, and it never got to a point where the tension really got all that much higher. It just kept stretching the belt out, and the belt was pretty shitty. It was dryer on it. So I brought it to the store, and I did get a serpentine belt that is the right size, and stuck that in there. Again, I have a lot of window to work with. So, and you know, just kind of pitched it so I got that to run as true as I could on the back pulley, because this is no longer has a curve to it anymore, which looks something like that, but that's what it is. It actually works quite well. It's got a lot of stickiness to it, so it doesn't want to slip on that shaft. And when I went to a smaller pulley to slow it down, again here, this ratio is slowed down, you lose contact area where, you know, you got a 4-inch pulley. This was probably about 8 inches of contact area that the belt's touching, and you're trying to drive it with. Now I'm down to, you know, what's that, 1.5 inches that's actually touching the belt. That's why I had to shrink it up so much. So let's see if I can do this without is that OSHA friendly? That's the adjusting knob. Let's I don't know if I want to do it running or not running, and holding the camera. All right, there's no way I can hold the camera and do it at the same time. So this is what's going to happen. You can take this guy and loosen it up. Just pull it, and that, there you go. Again, one-handed. Ratio will change. You just tighten it right back up. And so that's what it's got for a setup. So now that belt is a different ratio, and it slows it way down. So now that belt just crawling a lot slower than it was. I use a white mark around it, and I can count how many times that goes by to get an idea what a speed is. And I also have somewhere a gauge that, where did I put it, that you could read the speed in my stash. So I took that out and I was playing with that. You know? That's the pulley that was on it, the curve on it. So that was here, to give you an idea how much faster that was spinning. There it is. Okay. So here's what this thing does, is it can tell you how fast your speed is or your RPM. But essentially what you're doing is you put it on one of the belt or whatever turning at the rate. And you hit it, you let it go. It'll count for a predetermined set of time and shut off. So see how it stopped at 350 right there? And what they tell you to do is just to divide that by 2. So I'm running at 175 is my speed. So that's my slowest speed, and at the highest speed is at 360, I believe. 375 is my high speed. So that's a pretty good range. And I said it cut wood really good before. And with that belt that's on there, you can't really stall it out. It just, I mean, I'm pushing real hard into that, you know, and it doesn't even want to bog down at all. There it goes. So that would be where you finally give, you know. It will slip a little bit. I gotta get that out of there. But that's the idea. And again, it does have to stall at some point. I'll go back to normal. So that's good. That's exactly what I was looking for. I'm waiting for the metal blade to come in, which is the same size blade as this, and then I'll get to play with that setup and see how that works for us. Alright guys, again, thanks for watching, commenting, and subscribing, and when I get some a metal blade on here and some metal, we'll play with that, and we'll see how that does with this. All right, guys. Bye.